Imagine standing on another world, not through a telescope, not through animation, but through real eyes. Welcome to Mars. What you're about to witness isn't science fiction. It's not a simulation, a game, or an artist's guess. These are actual photographs, captured by machines we built, machines we sent across space, machines that lived and moved on a distant planet. For us. For years, these rovers crawled across alien soil, enduring dust storms, bitter cold, silence. But they didn't just survive, they observed, and they sent back something extraordinary, images so detailed, so hauntingly real, they reshape what we thought we knew about Mars. Through restored photos and billions of pixels, we now have a view of the red planet so clear, it feels like you could reach out and touch it. This is a journey into the heart of Mars. Not the Mars from textbooks or sci-fi movies, but the actual surface, sky, and history of a world that may once have held life and still hold secrets. So open your eyes. This isn't a dream, this is the real Mars. And you're finally seeing it for the first time. It's a question many have asked. If our phones shoot 4K video, why can't NASA show us Mars in motion? The answer isn't secrecy, it's physics. Mars is far, sometimes over 200 million miles from Earth. At that distance, communication becomes a balancing act of time, energy, and bandwidth. Imagine trying to stream a movie through a walkie-talkie across the solar system. Rovers like Curiosity can capture astonishingly high-res images, but sending those files back is agonizingly slow. When transmitting directly, the signal crawls along at about 32 kilobits per second. That's not a typo. It's slower than dial-up internet from the 1990s. There's a workaround: orbital relays. Satellites like the Mars Reconnaissance Orbiter act as routers in the sky, briefly picking up the rover's data and forwarding it to Earth at higher speeds. But here's the catch. These relays only pass overhead for about 8 minutes
Touchdown
per
confirmed.
That's
In the 10 months since the rover has landed, we've been busy.
Hours of video with just 8 minutes of Wi-Fi per day. So NASA makes a choice. Rather than sending 30 frames per second, they send single still frames, each one meticulously planned, each one filled with detail. Because on a planet with no moving trees, no rivers, no animals, one powerful image often says more than an entire video. And when those stills are sent back, piece by piece, Earth-based teams stitch them together, align them, enhance them. And the result isn't a live stream. It's something better, a window into a real place, frozen in time, waiting to be explored. And this is just the beginning, because now that you know why video is rare, it's time to discover how those still images become cinematic journeys, and how Mars finally came to life, frame by frame. If you've ever felt like you were standing on Mars, chances are it was because of this process. The rovers don't take wide-angle photos like your phone. They build the scene, tile by tile. Instead of snapping a single panorama, they scan the landscape one frame at a time. Like a typewriter made of glass and steel, their cameras sweep slowly across the horizon, capturing dozens, sometimes hundreds, of overlapping images. But when these files arrive on Earth, they aren't ready. For prime time, they're raw, fragmented, some overexposed, some full of shadows, sometimes dust obscures the lens. Sometimes the lighting shifts halfway through the session. Each of these fragments is just a piece of a puzzle, and before they reveal anything meaningful, scientists must first stitch the Martian world back together. It begins with alignment. Frame by frame, engineers calibrate the angles, correct distortions, match lighting, and adjust for camera drift. Then comes color correction, not to alter reality, but to balance what the rover's sensors captured in extreme conditions. Once the full mosaic is stitched, the magic begins. Motion is added, not animation, not fakery, just cinematic movement across a real static image. A slow pan, a gentle zoom, a drift over the Martian terrain. Why does that matter? Because motion gives context, it gives dimension. It tricks the brain into thinking, I'm there, I'm seeing this for myself. And in a way, you are. You're not watching a guess or a rendering or an AI hallucination. You're looking at a real moment, captured by a robot, on a planet millions of miles away, rebuilt with care, detail, and reverence. It's not just about what we see, it's about what we feel when we see it. And now that you know how these stunning images are created, it's time to see the most breathtaking one of all. A photograph so massive, so detailed, it captured 1.8 billion pixels of Martian history. Out of all the images ever sent from the surface of Mars, one stands above the rest, not just in beauty, but in sheer scale. In late 2019, over the course of several Martian days, the Curiosity rover did something extraordinary. It paused its climb up Mount Sharp to capture the most detailed surface mosaic in interplanetary history. Over 1,000 individual images were taken, each carefully planned, each perfectly aligned. The result? A panoramic masterpiece made of 1.8 billion pixels. To put that in perspective, if you printed this photo at full resolution, it would stretch wider than a football field. And you wouldn't be looking at pixels, you'd be seeing grains of soil, cracked rocks, wheel tracks in the dust. But this wasn't just a technical achievement. The image was captured in a place with enormous scientific significance. Glen Torridon, a region nestled at the base of Mount Sharp inside Gale Crater. Why Glen Torridon? Because its soil and stone carry the signature of clay minerals. And on Mars, clay means one thing: ancient water, not flash floods, not seasonal melt, but water that stayed, that pooled, that shaped the land over time. Scientists believe Glen Torridon may once have been the bed of a lake, fed by rivers, shielded from radiation, stable enough for life. Not today, not now, but billions of years ago when the planet's climate was very different. When Curiosity panned its cameras across this terrain, it wasn't just sightseeing, it was documenting strata, layers of history pressed into sediment. Subtle shifts in color hint at different minerals. Erosion patterns trace the path of ancient wind and water. This one image, silent and still, tells a story written over geological time. It's a map, a record, and perhaps a clue, because the presence of clay doesn't just suggest water, it raises a bigger question. Was this place ever habitable? On Earth, where there's persistent water, there's often life. Could the same have once been true here? It's one of the many mysteries still hidden beneath the Martian soil, and as we peer closer into the terrain, we start to look upward. Because on Mars, it's not just the ground that surprises us, it's the sky. When you picture the sky on Mars, what do you see? A harsh, angry red, a dusty haze, maybe something out of a movie, alien and ominous. The truth is far more beautiful and far more complicated. On most days, Mars wears a sky of muted golds and soft oranges, not bright red, but a pale mix of rust and peach. This is because the Martian atmosphere, though thin, is filled with fine dust particles. These particles scatter sunlight differently than the air on Earth. Here at home, nitrogen and oxygen scatter blue wavelengths, giving us our iconic blue skies. But on Mars, it's the longer red and orange wavelengths that get scattered. The result, a sky that feels like perpetual sunset. But then, something strange happens. At sunrise, at sunset, the Martian sky flips the script. Around the sun, the sky glows blue. That's not a trick. It's real, and it's the opposite of Earth, where our skies are blue and our sunsets are red. So what about all those Mars photos showing bright blue skies in the middle of the day? Are they fake? Not quite. Some of those images are white balanced, a technique used by scientists to simulate how Mars would look under Earth-like lighting. Why? Because geology matters. When scientists want to study the subtle tones in rock and soil, they sometimes adjust colors to see them as if lit by Earth's sun. So there are two versions of Mars. The true color view, what you'd see with your own eyes, and the white balanced view, what scientists use to reveal details otherwise hidden by haze. Both are real, both are valuable. They just tell different parts of the same story. And that story gets even deeper because the Martian sky isn't just colored by dust, it's shaped by it. During storms, the air grows thick with sediment. The world darkens, the colors shift. Some days, the sun itself becomes a faded ghost in the sky. But through it all, through haze, through dust, through thin air, our rovers keep watching. And what they've revealed is not just a landscape, but an atmosphere alive with movement and change. But Mars's skies are just part of the mystery, because it wasn't the sky that broke our hearts. It was what happened on the ground. Machines that were never meant to survive became explorers we'll never forget. Every great journey needs a pioneer. On Mars, there were two, Spirit and Opportunity, twin robotic explorers built by hand, launched into the unknown in 2003. Their mission, survive 90 Martian days, travel just over a kilometer, gather data, and then fade quietly into history. But that's not what happened. Spirit landed first, inside Gusev crater, a barren plain dusted with volcanic rock. The landscape was harsh, the winds relentless, and yet Spirit pressed forward. Slowly, patiently. Climbing the Columbia Hills, uncovering chemical signatures of ancient water and hints of hydrothermal activity. When one of Spirit's wheels failed, it didn't stop. It kept going. In reverse. Dragging its broken wheel through Martian soil, carving trenches that revealed minerals scientists had never seen before. In 2009, Spirit became trapped. Its wheels sunk deep into soft sand. Engineers fought to free her, but the planet wouldn't let go. She stayed where she was and turned her final days into science. For 6 Earth years, she worked. In the end, her last message was just data. No farewell, no fanfare, just the silence of dust settling across a brave machine. But on the other side of the planet, Opportunity was writing a different kind of story. She touched down in Meridiani Planum, in a crater just 22 meters wide. Within weeks, she discovered something historic. Tiny mineral spheres called blueberries, a clear sign that liquid water once flowed here. Then she kept going, across ridges, plains and craters, over 45 kilometers of Martian terrain, a distance no other rover has matched. She climbed Endeavour Crater, studied ancient rock beds, and survived brutal Martian winters. She became more than a robot. She became a symbol of resilience. People around the world followed her journey, not because she had a face, but because she had a purpose. She represented our will to explore, our refusal to give up, our belief that even machines can carry our curiosity farther than we imagined. And then, in 2018, came the storm. A planet-wide dust cloud swallowed the sky. The sun disappeared, and Opportunity, powered only by sunlight, went dark. Engineers sent command after command, over 1,000 attempts, hoping for a response, praying for a signal. But Opportunity never woke up. Her last known data, low power, no sunlight, fading hope. NASA interpreted her final transmission in human words: "My battery is low, and it's getting dark." She was only supposed to last 90 days. She gave us 15 years. Spirit and Opportunity didn't just explore Mars, they inspired Earth. And though they now sleep beneath Martian dust, their legacy lives on, in every rover that followed, and every heart that dared to care. But Mars wasn't done with us yet. Because something even smaller, even bolder, was about to take flight. For decades, we explored Mars on wheels, crawling over craters, climbing hills, following dusty trails left by our robotic pathfinders. But in 2021, something changed. For the first time in history, we took to the skies. Her name was Ingenuity. Just 1.8 kilograms, no bigger than a backpack. But her mission was audacious, to fly on another planet. The challenge? Mars's atmosphere is just 1% the thickness of Earth's. That's like trying to lift off from the top of Mount Everest on a planet with less gravity and no safety net. To make it work, her rotors had to spin 5 times faster than a normal helicopter, over 2,400 revolutions per minute. No human-made aircraft had ever attempted this, and no one was sure it would work. She launched alongside the Perseverance rover, a ride-along experiment, a test flight with a short checklist: fly 5 times, prove it's possible, then shut down. But Mars had other plans. On April 19, 2021, Ingenuity spun up her blades and lifted off. She hovered, stable, graceful, silent. And just like that, she became the first aircraft in history to fly on another world. But she didn't stop there. She kept flying, mapping routes, scouting terrain, guiding Perseverance from the air. Something no rover had ever had before. She flew over rocks and dunes. She helped scientists avoid hazards. She flew when the atmosphere was thin, when the temperatures dropped, and when the odds said she shouldn't. Every time her rotors turned, it was a reminder that Ingenuity isn't just a name. It's a mindset. What began as an experiment became a pathfinder. And now NASA knows the future of planetary exploration won't just roll across the surface. It will soar above it. One day we may fly swarm drones across Mars, send aerial robots through the skies of Titan, or glide through the clouds of Venus. And when that happens, when humanity finally conquers the skies of distant worlds, it will all trace back to a tiny helicopter that flew on Mars. But even this isn't the end, because all of it, every photo, every step, every flight, was building to something bigger. A single question that's haunted humanity for generations: are we alone? With every grain of Martian soil captured, every crater explored, every sky scanned for light, we've been chasing a single idea, not just to map a planet, not just to test our technology, but to reach the edge of a question humanity has carried for as long as we've looked at the stars. Are we alone? The images you've seen, billions of pixels stitched from thousands of frames, aren't just pretty pictures. They are clues. Proof that Mars was once a place of flowing water, sediment, clay, and maybe, just maybe, conditions where life could begin. Spirit saw signs in volcanic rock. Opportunity found the minerals water left behind. Curiosity climbed mountains made of ancient sediment. Ingenuity soared over ground no wheel had ever touched. Each mission a piece of the puzzle. And now, Perseverance is doing something even bolder, collecting samples from the Martian surface, preparing them to be sent back to Earth. Not tomorrow, not next year, but someday. And when those tiny sealed tubes finally return, when human hands open them, they might not just hold dust, they might hold answers to how planets form, to how water shapes worlds, to whether life is rare or universal. Because every mission to Mars has asked the same question in a different way, through drill samples, through aerial maps, through silent cameras waiting in the dust. The question isn't, was there ever water? We know the answer to that. Now the new question is, what else was there? And if Mars once had the right conditions for life, then maybe, just maybe, life didn't begin on Earth alone. This is the beauty of exploration, not in what we already know, but in what we're finally ready to discover. You've seen the wheels, the wings, the wonder. Now imagine what comes next. The story of Mars isn't over. and neither is ours. You've just traveled across a world where no human has ever walked, but where our machines have lived. A world shaped by wind, time, silence, and now, our curiosity. These weren't simulations. These weren't guesses. These were real. Images taken from the surface of Mars, by rovers that went farther than we ever expected, and by a tiny helicopter that dared to fly in skies we once thought untouchable. Mars isn't just dust and distance, it's a mirror, reflecting back to us the kind of questions only explorers ask. What's out there? What came before us? And how far can we go? If this journey stirred something in you, a sense of wonder, a shift in perspective, then don't let it end here. Like this video if the images changed how you see Mars. Subscribe if you want more stories that pull back the curtain on the universe. And share this with someone who still believes in the power of exploration. Because there's more coming, and the more of us who care, the more reasons we'll have to keep looking up. Thank you for watching. Stay curious, and I'll see you in the next one.